Hey guys, in this video I'm going to show you how to make a slow motion RBD explosion in Houdini, and I will also show you how to optimize the scene to improve simulation time and rendering time. So let's dive in. So the first step is to add a new geometry node. So you can dive inside, and here you can import an external 3D model by clicking on the new file node. If you want, you can download this project file with the link in the description. It will include all the model and all the textures. So here you can press P to open the parameter, and here you can click on this little icon to import an external 3D geometry. So I will click on it, and here I have my geo folder under my $heap, and I will import my first model. So here I have 4 models for these simulations, but let's start with one and single model, and later we can add the 3 others. So let's import the lychee number 1 and click on accept. So now let's put this geometry on the center of the scene, and to do that let's add a match size node. So here you can keep everything by default. It will put the model on the center of each axis. So now let's add a polyreduce node, and with the polyreduce node we can decrease the polygon number of this model, and in that case we can make the simulation with low res geometry. So here with the polyreduce I will reduce it to maybe something like 5%. In that case I have very low poly model, and you can see that I have only 700 points. So now let's create an attribute called variant. This is an integer attribute, and we will use that later to copy a different model randomly on our point. So let's add an attribute wrangle, and here to create the variant attribute you can type e for integer at variant is equal to 0 for this first geometry, and later we can copy that and add different model, and we can change the variant value for each individual model. So for now let's keep it like this, and you can add a null to specify this is the output of our first model. So we can rename it something like out lychee 1. So now let's create some points on the scene, and we can copy this geometry on those different. So to do that let's add a circle. You can also add a grid if you want. So here with the circle we can change the orientation. Instead of X and Y you can put it on X and Z, and here for the uniform scale you can increase it from 1 to 2, and you can increase the division number to 128. So now let's create some points on this geometry. So to do that let's add a scatter node, and here with the scatter node by default the value is at 1000. In my case I will put 250, but of course it's up to you. So that means we will get 250 lychee later on the simulation. So you can change this number at any time. So now let's add a copy to point to copy the geometry on those different points. So let's add the copy to point node. Here you can plug the geometry on the first input, and you can plug the point on the second input of the copy to points.
Imagine having access to over 40 hours of exclusive Houdini tutorials. And that library keeps growing every month with brand new content. On Artilabs, you'll find in-depth Houdini tutorials covering motion design, simulations, product visualization, and more. Plus, you get access to all project files so you can follow along step by step. And right now, we're offering an extra 20% off the annual membership, on top of the 10% discount already included when compared to the monthly plan. This exclusive deal is available for the first 30 people, so don't miss out. Click the link below. Your 20% discount is applied automatically. Secure your spot before it's gone.
And now you can see the result of this one. So now you can see that we have multiple lychee copies on those different points. So that means we have 250 lychees. So now let's add an attribute randomize on the points. So by default, the attribute randomize will randomize the color attribute. So we can remove that and replace it with the orient attribute. And here you can increase the dimension to 4. And now you can see that we have a random orientation for each individual pieces. So here we have lots of intersection between all of these models. So to remove that, we can run a first RBD simulations. So first, let's select the copy to point, and here you can click on pack and instance. Now let's add an assemble node, and here you can keep everything by default, just enable the create name attribute. Here you can add an attribute wrangle, and we can type e at found overlap is equal to 1. So now you can add an RBD bullet solver, and you can plug that to the first input. So here on this one you can go to the force tab, and you can disable the gravity, so you can put that to 0. So now you can run the simulation for this first RBD, and you can click on play, and you can see it will de-intersect every model. So now you can add a time shift just after the RBD bullet solver. So now you can freeze the simulation at the frame number 2. So you can add a time shift just after the RBD simulations. So here with the time shift, you can right click on this one, and you can click on delete channel, and you can freeze the simulation at the frame number 2. So in that case, we have all the model perfectly placed. So now you can select all of these. You can click on this little icon, and here you can rename it something like de-intersect. And you can put that in black, so press C and click on the little black icon. So now let's create the second RBD simulations. So we can add a match size node one more time. And here you can place all of these pieces at the bottom of the scene on the y-axis. So to do that, you can select the match size, and here on the justify y, you can put that to minimum. In that case, you can see that we have all of these pieces at the floor on the scenes. So now let's add an attribute delete. And here with the attribute delete, we can delete our velocity attribute. So now let's create a new velocity vector. So to do that, you can use the point velocity node. And here with the point velocity node, you can go to conical noise, and here you can enable these options, and you can visualize the velocity by clicking on the little eye icon, and here you can enable the velocity attribute. So now you can see that we have a velocity vector for the RBD simulation. So for now it's quite low. So you can increase the scale maybe at 5, and here you can play with a cone angle if you want to get more or less conical velocity. So in my case, I will put the value at something like 45. So now you can see that we have a velocity vector for each individual point, but you can see that the velocity vector is at the same length for every point. So we can add a bit of randomness by using the node called attribute adjust vector. And here by default, the attribute for this node is velocity, so we don't have to change anything here. And here you can see that we can change the direction and length of the vector, but in our case, we don't want to change the directions. We want to change only the length of those vectors to add a bit of randomness for each individual points. So let's change this setting to length only. So here you can keep the operation to add, and you can adjust that with maybe a random, can be a good options. So here you can play with minimum and maximum value to add some randomness into the length for the vectors. So maybe you can put that to 2 and that to 5. And here you can change the value distribution to uniform with remapping. In that case, you can control the randomness with a bit more precision here. So maybe we can play with the curve with maybe something like this, like this, like this, and here, here, and here. Of course, it's up to you. You can create your own ramps just to create some control over the randomness, and here you can play with the seed if you want. So it's up to you. You can change this value at any time. So now let's add an attribute wrangle, and now we can create a little slider to control the velocity value. So we can type v at v to control the velocity attribute, and you can type times equals, and here you can create a little channels. So we can rename it something like vel mult, and here you can create this little channel by clicking on this. So if you put the value at 1, nothing will change because the velocity is multiplied by 1. So that means don't change anything from the previous node. So if you put the value here at 0.5, so that means the velocity will be divided by 2. And if you put that to 2, so that means the velocity will be multiplied by 2. In my case, maybe I will increase it just a bit to 1.25. So in that case, I have something a bit more strong for the velocity. And now we can run the second RBD simulation. So you can type RBD bullet solver. And here you can plug this attribute wrangles to the first input of the RBD bullet solver. So here for the RBD bullet solver, you can go to properties. You can put the collision padding to 0. Here under collision, you can enable the ground plane. And here you can keep that to convex hull, and you can put that to 0. So here you can keep the gravity force enabled to get a bit more realistic result. So now you can go to the advanced tab, and here you can enable the bullet solver, and you can put the sleeping time at 0.
Ready to level up your Houdini pipeline? Get the Houdini script pack. Complete toolkit, 7 powerful tools today, plus every future release with free updates. Save time on composition, geometry splitting, material creation, and more. YouTube subscribers get 50% off with code TOOLKIT. Click the link in the description and transform your workflow today.
So now you can just display this node. You can hide the velocity vector by clicking on this, and now you can click on play to see the result. So you can click on file, save, and now you can click on play, and you can see that we have our RBD explosion. So of course you can play with the velocity vector here at any time. So you can play with the conical angles. You can play with the attribute adjust vector and also with the speed. So if I put that to 3, you can see that I have way more strong velocity for these pieces. So in my case, I will keep the value at 1.25. So now we have only one and single geometry for this simulation. So in our case, we will use 4 different pieces to add a bit more randomness and a bit more realistic result on the simulations. So we can duplicate all of these 3 times. So maybe we can add a color node to add different color on the pieces just to get a little preview. So for the first one, we can put that to red. Now we can duplicate all of these. Now we can replace the file with the lychee number 2. You can put the color in blue. Here you can duplicate it one more time. You can replace the file node with the lychee number 3. Here you can put that in green. And you can duplicate it one more time. And here you can replace the file node with the lychee number 4. And here you can put that in yellow. So now we have to change the variant attribute for each individual pieces. So for the first one, we have the variant at 0. For the second one, we put the variant at 1. For the third one, we put the variant at 2. And for the last one, we put the variant at 3. So now we can put that a bit up here, and you can select all these nodes, and you can add a merge node. So now we have everything in place. So I think this one is a bit small, so we can add a transform node, and we can put the scale at something like 1.25. So now to copy all this geometry randomly on those different points that we have created with the scatter node, we can use the attribute from pieces. And here you can put the geometry library on the second input, and you can put the point on the first input. And here in our case, the pieces attribute is the variant attribute that we have created with the attribute wrangles. And now you can put that here. So we can plug the geometry on the first input of the copy 2 points, and you can plug that to the second input of the copy 2 points. And here on the copy 2 point, we have the option to select a piece attribute, so you can enable these options, and in our case, it's the variant attribute. And you can see that we have copied randomly all those 4 pieces on the points. So now we can run the simulation one more time. So now you can see that we have this result. So for now, we are using a very low-res geometry to create these simulations, but we need to use the original 3D model to create very high-res and beautiful simulations. So to do that, you can copy everything until the copy 2 points. Here you can right-click, you can go to Actions, and here you can click on Create Reference Copy. So now you can put that to the left. So here we can remove the polyradius for every model. Here, instead of the polyradius, we can add a subdivide node. And in my case, I will put the subdivide depth at 1. So I will keep it by default, and I can copy paste that for every model. So now you can also add the material sub node just after the file node. So let's add the material. So here you can assign the lychee material for each individual pieces here. So let's copy and paste that. So for now, I don't have created any material, but later I can assign the material by clicking on these little icons. So now you can see that we have the original model here on the left, and we have the low-res geometry here on the right. So you can see they are placed at the exact same positions. So we have the high-res here and low-res on the right. So now we have to transform this high-res geometry based on the low-res simulation. So to do that, let's add a transform pieces node. So here you can put the high-res on the first input. And here you can take the simulation points of the RBD bullet solver for the second input here. So the output for the points is the last output here. So you can see simulation points. So you can take this one and plug it to the second input of the transform pieces. So now you can see the result of the RBD simulation. So you can click on play. And now you can see that we have simulated the high-res model very, very fast. So now let's add a time shift node. So you can take this one, right click, action, and you can click on create reference copy. So you can put this one here. So in that case, we can freeze the simulation at the frame number 2. Now let's copy the match size node from here, right click, actions, and create reference copy one more time. So you can copy that and place it here. So now you can see that we have the high-res geometry on the left here with the match size node, and we have the low-res at the exact same position here. So this is the low-res and this is the high-res. So now the simulation is freeze over time. So now we can do the second transform pieces. So let's add another one, transform pieces. And here you can plug that to the first input. And now we can take one more time the output points of this simulation for the transform pieces node. So you can take the last output here from the RBD bullet solver, and you can plug that to the second input of the transform pieces. Now you can visualize this node, and you can click on play, and you can see that we can simulate a very high-res geometry. So now you can create slow motion effect by adding a time shift node. And here with the time shift node, let's say that we want to start the simulation at the frame 5. We want to start the slow motion at the frame 18. Until the frame maybe 30, and then we can add a bit of speed. So to do that, let's select the time shift node, right click and delete channel. Here let's add the frame number 5 at the first frame, and you can add a keyframe by pressing Alt and left click. You can disable the integer frame. Now you can go to the frame, let's say 20, and we can add the frame 18. Now you can go to the frame, let's say 90, and you can add the frame maybe 30. Add another keyframe, and you can go to the frame 1 and 10, and you can add the frame maybe 45. So now you can select this, you can go to animation editor, press H, and now you can make a nice curve here for the motions. So you can put this one very fast. You can put this one here, and this one here, and this one very fast at the end. So now let's see the result of the slow motion RBD effect. Click on play, and you can see that we have something very nice. So now let's add a null to specify this is the output. And here you can rename it out RBD. So now you can copy that. You can go back to the object levels. Here you can disable this one and add a new geometry node. You can rename it render RBD. And here you can add an object merge. And you can paste the null here. So in that case, we can import the lychee here. And now you can select the object. You can go to the Redshift object tag. So if you don't have that, you can go to Redshift and add the object parameter. So here you can go to the instancing tab, and you can click on instance sub-level pack primitive. So in that case, you can get the simulations and the rendering time very, very fast. So you can simulate very high-res model, and you can create very nice slow motion effect. So that's it for today, guys. I hope you like it. Don't forget you can buy this project file with a link in the descriptions. See you in the next one. Bye-bye. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxa.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.